Good morning, Subudula Denna. I'm so happy that how many pages altogether do we have? Yes, NRI is coming. All together. Wow, what are these pages? Yeah, altogether 98, 90, let's say almost 100. We are in almost 50. So most probably next week we would be able to finish this thing. Okay, then be happy that you have only this one single paper class and you can do this. NRI is just on the way. Just let's wait for a second. That you are in the bed. All right. Good morning, you two. Let's start then. I was just saying, next day we definitely, I guess, finish this unit 14. Then you guys have only one single class. That's the Monday one that we have to go very mindfully. All right, so the next part is the chemical products related to plant sources. Again, that I'm reminding you guys, just continuously you have to read this note. Continuously just read. You don't have to memorize anything. Just continuously read. Don't waste your time on memorizing, but when you start to read, someday you would feel like, now I already remember this. Then you can just, go with like little more memory. Okay, chemical products related to plant sources. The first part is vinegar. Vinegar actually is the active ingredient in vinegar is acetic acid. Acetic acid is the active ingredient in vinegar. And toddy is subject to continued microbial activity. It is oxidized to acetic acid. Toddy comes from these trees. When you are cutting these flowers, it is giving this sort of a juice that is called the toddy, like hitul or like these, whatever these palm trees, okay, coconut or. During this, the amount of acetic acid increases to about 48%. So the maximum acetic acid content coming from this natural vinegar is 48%. The vinegar so prepared is called natural vinegar. Artificial vinegar is produced by diluting appropriately the acetic acid obtained by oxidation of ethanol produced from raw materials turned out by petroleum industry. So don't use this artificial vinegar. Always use this natural vinegar. So because it's coming from this petroleum refineries. Natural vinegar contains salt, simple sugars, esters, and alcohols in minute quantities. All right, that's all about vinegar. Production of ethanol is the next part, which is really important in Sri Lanka. Alcohols. Ethanol is used as a solvent for perfumes and scents, one of the uses. It is also used as a medium for chemical reactions. The use of ethanol as an environmental friendly renewable fuel is on increase. So as a fuel, we also use ethanol. Ethanol products, ethanol produced from biomasses by microbial activity is referred to as bioethanol. If you are getting ethanol from biomass, like active stuff, so that is called bioethanol. From plant residues or whatever those products, through those products. Industrially, ethanol is prepared by hydration of ethylene. Ethylene means C2H2, or fermentation of sugar or starch in the presence of yeast. Alcohol contained in alcoholic beverages is generated by various plant sources. Yeah, alcohols or the ethanol in these drinking alcoholic beverages, they are making from these different plants like We are using grapes to make wine and barley to make beer. Various cereals, fruit juice, molasses, which is a byproduct of the sugar industry. Molasses is sort of like, you may have seen this one, like let's say this in these honey bottles after a particular, like let's say if you keep a honey bottle for a couple of months, also that you would see that some sort of a solid part like sugar crystals are depositing. That actually is the molasses. So the molasses, which is a byproduct of the sugar industry, etc., are used to produce. Are you were like on the way? Good, yeah. Nice to see you too. What? Can we pretty hair again? Okay, just listen. As yeast cannot live in a concentrated solution of ethanol, the percentage of ethanol in fermented solution is around 12%. So the maximum ethanol percentage that naturally you can obtain by yeast is 12% because yeast cannot live more than that concentrated ethanol. Products with higher alcohol content are produced by distillating the aqueous solution obtained by fermentation. Okay, by this fractional distillation, we can get the higher percentages. In brandy, it's about 40%. By distilling wine, we are making brandy, arrack, about 40%. That is distilling coconut toddy. The maximum concentration of ethanol obtainable by the fractional distillation of aqueous ethanol is 96.5. This is called rectified spirit. So that purified to maximum concentration. As regards the current use of narcotics are pain-reducing drugs. And drugs in the world, medical specialist states that arrack is one of the most dangerous alcoholic beverage because it's addictive. Let's see what's in arrack available in the market. Its main content is ethanol. Active ingredient of arrack is ethanol. In the world today, there are many methods to produce ethanol. In Sri Lanka, too, ethanol is produced by some of them. Legally, ethanol is produced from fermented coconut toddy and molasses, which is a byproduct in the production of sugar and sugar from sugar cane. Coconut toddy is produced by fermentation of sweet toddy. Are you guys understanding this? I don't know how to, because I don't want to waste your time and money actually together, because for unit 14, that's why I'm just going faster, because unit 14, even if I'm not explaining, you can understand. I'm just giving a little extra push. Okay. Coconut toddy is produced by fermentation of sweet toddy, a sugar solution obtained by tapping the tender inflorescence of coconut tree. Soft flowers of coconut tree we are cutting. Have you guys seen this? Even TV or somewhere that they are cutting these flowers. Somehow, some sort of a method. It's like, you know, when you are just tapping two flowers, it's just dripping the juice. So that juice is sweet, and that's what we are using to make this toddy. Have you guys drink this toddy? That white color something? I have done, not until I feel like, you know, this alcoholic condition, drunken condition, but it's so like, you know, tasty. You can drink it a lot. I didn't, because it's like alcohol. Others, I was scared that I would get, you know, intoxicated. But that's so. Toddy is something very tasty. The spores of yeast floating. So once you are making this juice, then this spores of yeast floating in air. So in air, it's floating. So just floated yeast are coming onto this and deposit on this sweet toddy. Get deposited in the sweet toddy. Okay, during fermentation, these grow in the solution using sugar as a substrate. The enzyme produced by the yeast called yeast cause gradually converted sugar into ethanol and carbon dioxide. The enzyme is called sucrase. To degrade this sucrose into glucose and fructose, the enzyme is sucrase. And again, with yeast, they are just producing ethanol. Within a period of 2 days, sweet toddy turns into fermented toddy, and during this process, the sugar concentration gradually decreases. If fermented toddy is left to stay further, bacteria oxidize alcohols in the toddy, converting it to acetic acid. So sugar to alcohol to acetic acid. Therefore, the alcohol percentage decreases and acid percentage increases. So, okay, within 2 days' time, this is happening. Initially, you have only sugar. Sugar is producing ethanol. And ethanol comes with yeast. Then with the bacteria action, then let's say it's not making this acetic acid, so the maximum ethanol production stops here. But if you are having this bacteria to convert ethanol to acetic acid, so acetic acid is increasing. So when acetic acid increasing, see, ethanol become finally zero if you are not extracting ethanol whatever the proper time. All right, fractional distillation, that everything we did for equilibrium, so I'm just reading. The distillation technique uses separate components which are miscible and have different boiling points from the mixture of them is called fractional distillation. We separate mixture according to their boiling points. So these are the boiling points of this mixture in this ethanolic mixture. So the least boiling point is going for methanol. So when we are heating, first portion is methanol. Sometimes these this illegal Iraq, like Porarako, that people get die because they are not separating this part. When you are adding this methanol to methanol is so much poisonous to our body. So that's why sometimes that people are getting died by drinking these illegal alcohols. Except for coconut toddy, ethanol is produced from other plant materials also containing starch. Beet, potato, fruits, rice, and are examples. During the fermentation of these plant sources, compounds like esters, aldehydes, and ketones are also produced. These two add to the aqueous mixture if their boiling points fall within the boiling point range of ethanol. They also vaporize with ethanol and pass into the distillate containing ethanol. So if their boiling points are matching, not only the ethanol, other impurities can get there. In this process, the first distillate mainly contains methanol because the lowest boiling point is going to methanol. That's the lowest. In this process, the first distillate mainly contains methanol. This is toxic and is used as wine spirit. The second fraction of the distillation mainly contains ethanol. Wine spirit is using for this lighting these wine spirit little lamps. Have you guys seen at labs? That glass, sort of a very teeny like glass color, some sort of a lamps, like they are using methanol just to lit that. When you are not using Bunsen flame, sometimes they are using that. I don't know whether you have it in school labs. Okay. The second fraction of the distillation mainly contains ethanol. The third fraction obtained at higher temperature contains higher alcohols, and that is called fusel oil. Okay, that's all about alcohols, ethanol, and vinegar. Then we are moving on to essential oil. This part we did for steam distillation. Water, insoluble volatile liquids. So these liquids supposed to be volatile, but supposed to be also water insoluble. Extracted from plant materials are known as essential oils. Various essential oils have a characteristic smell of their own. They add fragrance to food and increases appetite. Essential oils are also used to make perfumes. In the commercial field of the world today, there is a huge demand for perfumes and flavors. History says that even kings are using it. Essential oils are obtained from plants such as cinnamon, clove, citronella, and cardamom. Citronella means pangiri. Do you have this experience, pangiri? I don't remember exactly, but as I remember, that has some sort of a little weird, like you can't bear this smell, citronella smell. And wintergreen. Wintergreen is again same sort of like a plant which is giving this good smell, some sort of a smell. In plants, there are special body parts which contain essential oils. Before 2019, this was out of syllabus. Before 2012, between 2012 and 2019, they were inclusive to syllabus. So whenever there are these questions that we did under organic chemistry, remember just a couple of questions. So they were expecting you to remember this. Understood? So this part just you can just stick somewhere, just read, or otherwise you can just put the this page number 51 on the first page of your this resource book, so you can read that continuously. Whatever the page number in your one. If you go with normal pages, yeah, it's again 51. Just write that page number so you can read that frequently. All right. If you are getting essential oils from root, examples are cinnamon and couscous. That's savandara. Have you guys seen this savandara? Savandara is like savandara roots are using actually. So they have some sort of a good smell. In ancient time, now you guys are using different fragrance, like fragrant tissues are there for wardrobes. Earlier they were using this sandalwood and savandara to make good smell in your wardrobes in ancient time, like our grandma's time. Stem, sandalwood stem. That have you guys seen the sandalwood? No? Yeah, just like piece of this wood sticks kind of, yeah. And you guys definitely know cinnamon. That's bark. Then leaf, citronella, lemongrass. What is lemongrass? Say that lemongrass has this this kind of a little shoot, like the spring onion kind of, but it's very tough. And eucalyptus and cinnamon. I have not that exact idea what eucalyptus. Just remember. Buds, clove, that everybody know that. Then flower, jasmine, rose. Fruits, orange, lemon. Seeds, cardamom, nutmeg, very famous nutmeg. For Dhammika Panya, they were using like hundreds of thousands of nutmegs. Remember that in TV news, even they were like, there are suppliers for these nuts. But nutmeg tastes so good in food. Methods of extracting essential oils: steam distillation, solvent extraction, and pressing. We did both steam distillation, and the last little part of equilibrium is solvent extraction. Okay, Ramli, how do you feel about that? Exam is coming on November. Come on. Yeah. Yeah, it's nervous, but you know that you are in right path. Darling, you? But you guys are preparing. I don't know, my personal view is maybe least they would postpone 1 month. That's what I'm thinking. So anyway, let's stick to that date. So let's tomorrow on Monday, let's talk that then our time wouldn't be enough for full papers. For these classified and everything, it's all right. At least I need to do like 10 full papers. Then we need like 10 weeks. That is 2.5 months. I don't know whether we would be able to get that many. Then let's say that we are doing 2 classes, like 1 class at another time, 1 class at another time. Let's count how many weeks once we can specify. And be prepared with other 2 subjects as well. Are you guys now giving more time on chemistry to other 2? Are you doing that? Don't do that. You don't do that, though. I know when you are getting a good A pass, like with this part, you can reach almost 100 marks. Have that faith. But still, you need other 2 to go like well, because there was, I told you guys, 2 students were there, like 2 A's and 1 C. One could go to medical faculty, the other one could. She passed for biology. See, she is brainier, but still she couldn't go to medical faculty. Don't let this happen to you, because you 2 are really, really brainy. I'm not just saying that just to convince you or motivate you. I'm just saying that it's so like, it's like so, it would be so like sin kind of something if you couldn't enter these medical faculties in your first try. You both are really talented. Okay, have this said that you can do this. Okay. Even we are done this theory class, if you want to ask anything, whatever the time, we can make like online these Zoom class, or even Sinhala, if you feel bored, if you want to talk to me, if you want some sort of like special support or something, anybody or you do, just talk to me. We can fix the time at night time, so I can just get on with you, okay? Whatever it is until we finish the exam. Just remember, I'm always with you even we finish this video, okay? Okay, steam distillation. Many essential oils are likely to decompose or polymerize under the influence of heat. Therefore, heating them to higher temperature is not suitable. So, they are subjected to steam distillation and extracted under low temperatures. This phenomenon can be explained by the law of partial pressure, that is, the Dalton's law of partial pressure. When the systems contain water and plant parts with essential oils are heated, those tissues are damaged and essential oils liberate. The gaseous phase of the steam contains water vapor plus volatile compounds. At the temperature at which the system boils, the sum of the pressures exerted by water vapor and the essential oil vapor is equal to the outer atmospheric pressure. It simply says this. Let me explain this. Okay, when the internal pressure equals our external pressure, it starts to boil. Partial pressure of water vapor, because they are vaporizing independently. So partial pressure, so that equals to what? Saturated vapor pressure. So PA equals P naught A. And PB equals P naught B. So that according to Dalton's law of partial pressure, PA plus PB equals PT. So that P naught A plus P naught B equals total pressure. Saturated vapor pressures together gives the partial total pressure because they are vaporizing independently from each other, because these are immiscible. They are not mixing. Partial pressure equals saturated vapor pressure, that is pH2O, and partial pressure of whatever the essential oil equals saturated vapor pressure of that equals PA. If the total pressure is P, you can write like this: P naught H2O plus P naught A equals total pressure. And yeah, then the other principle that you should know is then that the total pressure is always greater than P naught H2O, and PT is always greater than P naught A. Then if you go with T naught of this T naught H2O, this is the other way around. Total mixture has a lower boiling point. So you are having cold or something. Really? Why? Got wet or had cold something or what? Remember, I told you, once you're done with the exam, your body is mine. You need to get my permission if you are eating something which is sensitive to you. Senara, this is the last time. Okay, avoid all these unnecessary stuff until you go with this exam. After that, non-ice cream, forward cake. Don't you want a hot water or something? Be really, really careful because your health is really, really important to maintain this good study. When the total pressure becomes equal to the atmospheric pressure, the mixture boils. The boiling point of this mixture is lower than the boiling point of pure water and the boiling point of essential oil. But we know that boiling point of water is very, very low and it's less than 100. Therefore, essential oil can be distilled at a temperature below 100 degrees Celsius and the boiling point of the essential oil is always less than boiling point of the essential oil. This setup, and this is a steam generator. It generates steam and it is feeding steam here. At the same time, this is the plant residue. We are boiling it continuously. So both water and essential oil boils passing through. This is the condenser. Through condenser, so we can add these two together. When you are using a separatory funnel like this, let's say we have two different phases, red one and blue one, then we can separate red part first, then this middle part separately, and then blue part. First the blue part, then the red part. So that this is the only part which is coming with water. We can use the solvent extraction, another method to remove this water from this essential oil. Steam produced by the steam generator is passed into the vessel which has plant material containing the essential oil. As steam is sent separately or from a steam generator, its volumetric flow can be controlled. It is an advantage. When steam enters into the vessel containing plant parts, as plant cells destroyed due to the heat of the steam, volatile compounds release. While vapor is condensed, certain amount of water vapor is accumulated in it. Water vapor and essential oil vapor exist above the liquid water by the continuous flow of water vapor. When the essential oil in the plant material comes into the vapor phase along with water, then, okay. However, as water vapor flows continuously, the vapor coming out of the vessel contains essential oil vapor as well as water vapor. When the vapor is passed through a condenser and cooled, the distillate is obtained with two layers of water plus essential oil, so we can separate them easily. Example, main component in cinnamon oil, which is obtained by the steam distillation of various parts of the cinnamon tree, leaf, eugenol, bark, cinnamaldehyde, root, camphor, main constituent in citronella. Citronella is also geraniol. These three coming from cinnamon tree, and this is from citronella. In citronella, but in citronella, main ingredient also geraniol. Solvent extraction that we already did. Remember that we can extract like using one time, or then remember that we did with 100 cubic centimeter, then twice 15 to 50, then 4 times each 25. That method I explained. Solvent extraction. The principle of this is the disadvantage of the essential oil in a solvent in which it is soluble. Yeah. This is dissolving in something more. The solubility of essential oil in water is very low. Nevertheless, they are very soluble in organic solvents. We can use as organic solvents petroleum ether, chloroform, toluene, ethanol. What is toluene? Yeah. That knowledge, that instant things coming to your mind, that's why you need this full papers. Because the whole syllabus is gathered into one place. Plant materials are shaken with such a solvent, majority of the essential oil passed into the solvent. The solvent is removed by vaporization or by some other means, thereby separating the essential oil. And the next part is pressing. This press coconut oil is best for your hair, but you have to make sure that when you're pressing, you're adding this wax and stuff, and it's totally pure, because pressing means you are not using even little bit of this heat. So it's all these good ingredients are saving. By applying a suitable pressure on plant materials, the volatile oils in them could be obtained. If pressing is done with another absorbent, the essential oil is absorbed into it. For example, when a plant material is pressed between two glass slides coated with wax, essential oil in it is absorbed into wax. Essential oil can then be extracted from wax using another solvent or ether. As an example, ether. Pressing method is rarely used because the yield is poor. Oil gets mixed up with other organic substances. In the extraction of oil from cardamom seeds, pressing method is also used. Extraction of cinnamon oil is mainly done in areas of Ambalangoda, Hikkaduwa, and Baddegama. First, cinnamon leaves are dried in air for 2-3 days in a shady place. Extraction of oil is easier from dried leaves than fresh leaves. During distillation, essential oil can easily be removed when cuticle of the leaves are broken. Cuticle is I think you guys know that, the outermost layer, and cuticle is damaging when you're drying them. Cuticles of the leaves are broken. It has been found that the leaves of the middle age are more suitable than the tender or more matured leaves for oil extraction. Not too mature, not too young. Earlier, copper boilers were used for distillation, but copper reacts with eugenol in the oil, giving a dark color of the oil. Therefore, at present, stainless steel or aluminum is used instead of copper. Generally, citronella is grown in Hambantota district. There are 3 main varieties of citronella: Heen Pangiri, Simbapogon nardus. Simbapogon nardus, I don't think you would need to remember. Mahapangiri, Cambopogon Ventarianus, then Lena Buttapangiri. Of these, the first 2 types are native or endemic to Sri Lanka. This Mahapangiri has been introduced by Philippines. The value of citronella oil depends on the occurrence of the compound geraniol. Geraniol is an unsaturated aliphatic alcohol. Symphogon Vintarianus has a greater, that is Mahapangiri, greater demand because its geraniol content is high. All right, this is again, they have added newly to this syllabus, and this is the equation for biodiesel. See the difference. For, let's say this is not there, and then you're having this sodium here. What is this? This is the production of soap. Just dissociating these esters. Sodium salt of these fatty acids are soap, but this time you are making another ester. Addition of sodium hydroxide. This is breaking, and now this is the biodiesel part. This part plus this is the biodiesel. So one of the disadvantage formation of biodiesel is formation of soap. This is the ester, methanol, sodium hydroxide. This is the fatty acid methanol ester, FAME, fatty acid methanol ester or biodiesel. Same glycerol that we get as production of salt. Knowing that equation, you can understand the rest of the part very easily. And just mark this topic is important because they talked a lot during these workshops. Once they are introducing this syllabus in 2019. Okay. You don't have you can keep this for a couple of days, then you can bring it back. Just read this a couple of times, then once you feel comfortable, then bring it back. I think you are reading this soft copy. Okay. I think that has all this information that I have written that extra. Okay. Biodiesel. With the production of, I want to give you guys. Oh man, how about this sort of? Yes, it really work actually. It's not necessary for the photocopy. You can just keep it like for a couple of more weeks. Anyway, you're going to fill your one, I guess. Will you have enough time for that? Really? Yeah, it's 24 because I wanted, you both did Roman easy. I made it to 27. Is the blow is coming to you? Okay. That, okay, I guess. Yeah, blower stop blows. Oh no, it's okay. Just let me know if the blow is coming. I can stop it then. Don't wait too long. Like if you, I'm not that sensitive because no, I knew that I would like ask that is okay because you both are not like having these climate conditions. I'm concentrating to give the best chemistry. If you want to write something with a pencil, you can go on. Like if you want to write the first page something or something like that. Okay. With the production of engines which can use petroleum fuel efficiency, a rapid development in the field of transport occurred. Just some normal information. The modern civilization, the main source of power is petroleum fuel. Easy usage and ability to use safely are their special features. Therefore, extraction of petroleum widened rapidly. Petroleum fuel is a non-renewable source of energy. Therefore, in the near future, all the petroleum resources in the world will be exhausted. Moreover, in the burning of the petroleum fuel, carbon occurs as fossils is converted into carbon dioxide. It increases the amount of carbon dioxide in the atmosphere and engenders severe environmental problems such as global warming. That's again, we can talk later, global warming. For this reason, attention is being drawn towards the production of energy using renewable sources. Biodiesel is such a renewable fuel, and actually it's not renewable because they are using these plants and plants are not growing as fast as they are cutting them. Biodiesel is produced from non-volatile plant oils. Plant oils is a renewable resource. Therefore, combustion of them does not cause increase in the carbon dioxide content in the atmosphere. They say so. Okay. Plants use, we are using the plant. Plants are making plant oils. Those are the ester part. To that ester, we have to add methanol externally. Then we are making the biodiesel. That biodiesel are using for thermal energy. At the same time, as a byproduct, it's releasing this glycerol. And when you are burning these biodiesel to get this thermal energy, it's releasing carbon dioxide. But carbon dioxide in atmosphere, with the support of solar energy, we are turning them back to plant. So this is so promising, but you guys know that plants are not growing as fast as this burning of fuels. And also the methanol is supposed to come from this natural source as well. Methanol is essential to produce biodiesel. Methanol is obtained from the product of the petroleum industry. That's again a disadvantage. Therefore, when biodiesel is obtained using methanol, it's not a biodiesel produced from 100% renewable resources. Hence, attention is being focused on the production of methanol using carbohydrates and other biomasses employing microorganisms. Even if we can get methanol again from biomass, that's 100% biodiesel again. Methanol so produced is called biomethanol. Biodiesel produced using biomethanol is biodiesel 100% based on renewable raw materials. Biodiesel is produced from the triglycerides present in plant oils. The reaction that converts the fatty acid of these triglycerides into methyl ester, which are fatty acid methyl ester or FAME, is referred to as a trans-esterification reaction. So reaction of this ester with methanol, because we are converting one ester to another ester. So we are using the word trans for that, trans-esterification reaction. Here one ester is converted to another ester. A sodium hydroxide solution is used as a catalyst. Biodiesel and glycerol are formed. Are immiscible and separate out into two layers. The main byproduct of this production is glycerol. Hence, biodiesel is a mixture of several methyl esters in fatty acids. Biodiesel that has low density floats on the glycerol layer. So the biodiesel density is lower so that it is floating on glycerol layer. So we can separate. In plant oils, if plant oils contain free fatty acids of the type RCOOH, see, they may react with sodium hydroxide to give soap, because this is the formula of soap, sodium salt of carboxylic acid. If soap is formed, then it's making this foam. During mixing, they are making these bubbles. Foam is also formed, which inhibits the catalytic action. Thus, in plant oils used for this purpose, free fatty acid content should be less than 2%. By weight to weight, the acid value should be 0.1 milligrams per gram of potassium hydroxide. It simply means when we are using this potassium hydroxide to neutralize this fatty acid, how much supposed to be neutralized using the fatty acid content is supposed to be 0.1 milligrams in 1 gram. Production of biodiesel, there are like 5 steps. Treating the plant oil taken as a raw material, so that to remove these other fatty acids and everything. Preparation of the catalyst mixture, so that is the sodium hydroxide mixture. Reacting triglycerides with methanol with this catalyst. Then separation of product. Then purify that product from crude biodiesel. Step 1. Fatty acid, free fatty acid and non-saponifiable. Saponification is a reaction of formation of what? Saponification. That's the soap production, that reaction. That is the ester plus ester addition of sodium hydroxide, making this sodium salts of carboxylic acid, that is saponification. So free fatty acids are there which are going through saponification to make soap, but there are some other fatty acids which are not going through saponification. Those are called non-saponifiable compounds in the plant oils are removed. This enables to have high yield for the trans-esterification reaction and mainly a high level of purity of the biodiesel obtained. Step 2. Sodium hydroxide catalyst is dissolved in methanol. Afterwards, the solution is mixed with triglycerides, plant oils. It is very important that the alcohol does not contain water. The amount of methanol used is also very important. Although the methanol triglyceride ratio is 1:3 in that equation, methanol is added a little excess. As the reaction is reversible, this makes the reaction more efficient to go through forward direction. However, methanol is not added in large excess because removal of methanol from biodiesel is difficult. To give forward reaction faster, adding methanol but little excess, not to having that issues to remove that after reaction done. In addition to sodium hydroxide, compounds such as potassium hydroxide and sodium methoxide NaOCH3 are used as homogeneous catalysts. Compounds like magnesium oxide and zinc oxide can be used as heterogeneous catalysts. These are solids. Homogeneous means aqueous or liquid. Then step 3. Since the alcohol and plant oil are immiscible, they are mixed with continuous stirring while the temperature is maintained between 50 to 60. It's same as soap. Soap and sodium hydroxide, two different ester and sodium hydroxide are immiscible. Same way, you have to continuously stir for this mixture. The trans-esterification reaction occurs here, produce biodiesel and glycerol. Step 4. The main products exist as two phases because they do not mix. The upper layer consists of biodiesel, unreacted triglycerides and diglycerides, and glycerol. Triglycerides mean this is the triglycerides, and if you have this only this part, that is the triglyceride. The main products exist as two phases because they do not mix. The upper layer consists of biodiesel, unreacted triglycerides, triglycerides, and glycerol, and methanol in small amounts. Lower layer consists glycerol with excess methanol and the catalyst. After the separation of the phases, these layers are separated. Fifth step. When the biodiesel phase is washed with water, glycerol and methanol and the catalyst dissolved in it can be removed. Whatever the part dissolving in water can be removed. Finally, it is possible to remove water. So after that, we are removing the water. Remaining methanol may occur in both the layers of biodiesel and glycerol as an impurity. By separating and heating the layers, methanol contained in them can be removed. This methanol can be reused. Water is bubbled through biodiesel to purify it by removing sodium hydroxide and glycerol, which are present in it as impurity. Then water or moisture sticking to biodiesel is removed. You can dry then to remove water. See the main reaction we are breaking here, and this carboxylic acid part reacting with this methanol to make this ester. In order to prepare a sample of biodiesel, a solution prepared by, okay, when you are going with unit 14, you don't have to read everything and memorize everything. Only like It's not like you are memorizing biology. When you are memorizing biology, each and every single step, that order you have to remember. But here you don't have to waste your time on that, okay? In order to prepare a sample of biodiesel, a solution prepared by dissolving 0.75 grams of sodium hydroxide in 26 grams of methanol and 250 grams of soy oil. So you can do it even in the lab. Petroleum fuel is a non-renewable source of energy. Petroleum, which is limited natural resource, is not uniformly distributed throughout the whole world geographically. Therefore, crude oil has become a very strong and crucial factor in international relations and international politics. As crude oil is used to produce petroleum fuel and the organic compounds obtained from the byproducts are used to produce medicine and monomers required to make plastics and artificial rubber, petroleum industry has become the motive force of the modern human civilization. With the combustion of petroleum fuels obtained from the underground crude oil, the carbon dioxide content in the atmosphere rises. Increasing of global warming due to this is a booming threat for the modern human civilization. Extra knowledge, if you need, you can just read. So biodiesel done, then they are talking about this environmental impact. Okay, so the first part is this production part. So we are done with that. See, all these topics are really, really short. Just read a couple of times, then you are in the memory. Trust me, just read. Don't waste time for memorizing. Read frequently. Then we are moving on to the second part. Unit 14, earlier they had environmental chemistry one part, industrial chemistry another part. Now they have added together. Industrial part is done. Now the environmental impact, that part. All right. Chemistry of air pollution caused by industrial emission. First one is acid rain. Rain is one component of the water cycle. From the vaporization of water from various sources, in the Earth's surface, water enters the atmosphere. Have they shown the water cycle? No. Can you go to the first page? No, it's not there. It's not there. Water cycle was there in, I think, the last version. Surface, water enters the atmosphere. The condensation of this gaseous water due to various factors at the atmosphere and returning back to the surface of the earth is called precipitation. Condensation of atmospheric, whatever this moisture to water is condensation, precipitation. There are several forms of precipitation. Rain is written as liquid water. Return in solid forms occurs as snow. That is very beautiful experience. If you are not living in very, very cold areas, then I think you have that experience. Snow? Are you living in the area that snowing in there? Okay. And here's, have you experienced hail? Really? Yeah, here's Ramudi, like larger, like they can be go like from this peppercorn size to larger like stone size. Have you experienced that sometimes like hairs were so huge that dropping onto these vehicle roofs and they are getting this like, yeah, in Canada there are these like Canada is really, really like cold country. When hairs are really larger, you can go outside. It can damage, like, you know, it can make you. So those are hairs. In addition, respiration also occurs by condensation into tiny droplets. That's aerosols. Aerosols that we have this experience in this aerosol sprays of this body sprays. resulting in mist and fogs. Whatever is the way of return, the water coming back to Earth from the atmosphere is the purest part of the hydrologic cycle, that is water cycle. Except the solid particles in the atmosphere and some dissolved gases like nitrogen, oxygen, and carbon dioxide, there is no other substance in atmospheric water. Earlier, like in ancient time, that is so purest, but now when they are coming down, percolating down even as rain, it is coming to this highly polluted atmospheric part, so they are absorbing these polluted particles. Of the gases, dissolved carbon dioxide has drawn much attention. That is because when atmospheric carbon dioxide dissolves in water, it combines with water to form a weak acid named carbonic acid. Even when we are leaving normal distilled water outside, the distilled water getting absorbed with carbon dioxide. And this can have this weak dissociation to release H+ to the media. Therefore, the pH of rainwater is little less than pH of natural water, so it's acidic. Based on the present carbon dioxide composition in the air, 400 milligrams per cubic decimeter or 0.04%, the minimum pH value of rainwater is 5.6. Only if carbon dioxide dissolves in water and decrease the pH is decreasing only up to 5.6. So it's acidic, but it's not highly acidic. That is, rainwater is slightly acidic even in the absence of any other factor affecting it. This mild acidity is not harmful to aquatic animals, man, or any other water-related activity. Because even in ancient time, the carbon dioxide was in atmosphere. So we always having this acidic rainwater, but that wasn't ever affected us other than this acid rains. Acid rains are not coming through carbon dioxide, remember that. This is the ordinary situation. So this is normal, ordinary. It's not acidic. But due to various natural and human activities, more acidic gases are added to the atmosphere. These are gaseous acidic oxides of nitrogen, NOx, like NO2, NO3, and gaseous acidic oxides of SOx, mean SO2 and SO3. Nitric oxide, nitrogen dioxide, can be considered as gaseous acidic oxides of nitrogen. Sulfur dioxide and sulfur trioxide are gaseous acidic oxides of sulfur. Ways of gaseous acidic oxides of nitrogen enters at atmosphere. So how do these nitrogen oxides are coming to atmosphere? Natural processor, but the impact is less. During lightning, where the temperature is high, atmospheric nitrogen reacts with atmospheric oxygen, forming nitric oxide and nitrogen dioxide. Okay, usually nitrogen and oxygen doesn't react with each other, but during the lightning, they are giving this energy which is greater than 900, let's say 945 kilojoules per mole, which can break the N triple bond N. Then only that can react with oxygen or oxidize into give NO. But NO is easily can oxidize with O2 to give NO2. NO and NO2 are also produced by volcanic eruptions and nitrification bacteria. Nitrification bacteria are nitrogen-fixing bacteria living in the environment. Gaseous acidic compounds of nitrogen are also produced by the oxidation of ammonia. See, we use ammonia we oxidize ammonia to get this nitric acid. That's the Oswald process that we did already. In the atmosphere, which is produced by the microbial decomposition. Microbials can also do that, okay? Of nitrogenous compounds under anaerobic condition. when there is no oxygen anaerobic condition, that ammonia can convert to these acidic compounds as well. The amount of acidic gaseous compounds released to the atmosphere by all these natural processes are very small. So even naturally, that nitrogen gases come into environment or atmosphere, that's very small. Thus, the composition of naturally produced acidic gases of nitrogen in the atmosphere is very small and has no significant effect on making rainwater acidic. So they are adding these sentences for MCQs. That's the memory you guys need. It's not you need to remember each and every single point orderly. Human activities that has the high impact. The main anthropogenic, like human related activity that emits gaseous acidic compounds of nitrogen to the atmosphere is the burning of fuel in motor vehicles. So that is the main disadvantage. Internal combustion engines produce energy by combusting liquid fuel in air under a very high pressure and high temperature. Atmospheric nitrogen also is inert under normal condition. So under normal condition, atmospheric nitrogen is inert. But when combustion of liquid fuel, they are producing very high temperature, same as that temperature coming through lightning. Under normal condition, reacts with oxygen under these conditions of high pressure and temperature, mainly producing nitric oxide. Same reaction, but this time with man-made issues. Nitric oxide gets oxidized further into the atmosphere, giving nitrogen dioxide. Yes. Acidic NOx produced by human activities makes rainwater acidic. Ways to adding oxides of sulfur to the atmosphere. Now let's see SO2 and SO3. Natural ways. Again, they say impact is less. In the volcanic eruption, ash and gases containing huge amount of sulfur dioxide and freed all these directly enter the atmosphere. As a result of microbial activities taking place under anaerobic conditions in the sediments of the bottom of the ocean and water resources, hydrogen sulfide gas is produced. Oxidation of this gas in the atmosphere gives sulfur dioxide. So initially H2S. H2S is oxidizing to make SO2. However, the sulfur dioxide concentration in the atmosphere remains at a very low level because sulfur dioxide produced as above spread across a very large area of the atmosphere, because so that it's getting diluted in atmosphere. Sulfur dioxide gas entering the atmosphere due to natural ways hardly contributes to make the rainwater acidic. Acid rains restricted to the relevant areas have been reported after volcanic eruptions, only closer to volcanoes. Okay, human activities has high impact. Compounds of sulfur include as impurities in less volatile fuels such as diesel and furnace oil produced during the refining of crude oil. These compounds containing sulfur turn into sulfur dioxide on combustion and enter the atmosphere. Further, elemental sulfur and sulfur compounds such as ferrous sulfide present as impurities in coal get oxidized during the combustion of coal and enter the atmosphere as sulfur dioxide. Sulfur dioxide produced by human activities like this largely adds on to the atmosphere at certain specific regions. For this reason, there could be a very high concentration of sulfur dioxide in the areas around such sites. Example, coal power plant stations. Acidic oxides of sulfur SOx, SO2 and SO3 generated by such human activities cause acidity of rainwater. How pH is lowered in rainwater by acidic gases? Okay, NO is produced during the combustion of engines. That's NO. That NO oxidizes with O2 to give NO2. That NO2 oxidizes again and dissolving and reacting with water, +4, here +5 nitrogen, making this strong acid nitric acid. And likewise, SO2 gas entering the air is further oxidizing to SO3. SO3 reacts with water vapor to form sulfuric acid, you guys know, which is strong acid. In the presence of SO2, gas also react with water vapor. Okay, they can enter, SO2 reacts with water vapor and SO3 reacts with water vapor. SO2 separately gives H2SO3, which is a weak acid. But this SO2 is oxidizing and dissolving in water vapor gives sulfuric, or SO3 directly dissolving in water gives sulfuric. The compounds nitric and sulfuric form above are strong acids. They completely ionize in water, adding H2O plus ions to water in large amounts. See, they are releasing H2O plus to water in large amounts. Dead fish and dead plants. Because of the H2O plus ions added to water by the strong acids, the pH value of the water decreases below the pH caused by carbon dioxide formed by dissolving carbon dioxide gas, carbonic acid, okay? Lowering the pH of rainwater below 5.6. 5.6 is responsible from carbon dioxide, but acid water is below that, this. By adding strong acids to the rain is called acidification of air or formation of acid rain. So acid rain is supposed to be pH less than 5.6. High acidity of water leads to many problems. Effects of the acidification of water. Aquatic organisms are very sensitive to the change of pH in water. Therefore, even a small drop in pH in water is harmful to them. This causes changes of behavioral patterns, retardation of organogeny. What is that word? Organogeny mean developing of plants and animals. Organic genetic, generation of organic stuff. Organogeny. And destruction of eggs and immature organisms of fish and other aquatic organisms, etc. This is detrimental to biodiversity. Death of coral polyps. Polyps, I guess you guys know that some sort of animals, tiny soft-bodied organisms, polyps. They're inclusive to biology. Okay then. Responsible for the formation of coral reefs, stops their formation and bleaches the reefs. Have you guys gone through this sea diving or snorkeling? No? Yes or no? Just try at least once. Unimaginably beautiful world is there. Whenever I'm going down the sea, because they are giving like 15 minutes or 30 minutes, that's how we are paying. Then you have to come up. But I don't feel like coming up. It's that beautiful. You know all these sceneries that you see through this Discovery and all these channels? Exactly same beautiful. It's same beautiful. It's not like exaggeration. Those are, and down there like all these corals and beautiful fish. And they are giving us these biscuits that we can feed them. So very first, so you feel like so scared that you are just holding your biscuit like this. Then like when this huge, sometimes huge fish are coming, you would feel like maybe they would just swallow your full hand. Then I'm just throwing it away. Then they're like, no, ma'am, just keep it. They are not doing that. Sometimes they are just like biting your fingers. But that's a very, very beautiful, very amazing experience. In Sri Lanka, you can go like, it's not like very expensive. Someday you can do that. And next time when your parents are here, so now you can also ask them to go for this snorkeling or this. Yeah. Yeah, very well. And after the exam, Ramudi, okay? After the exam, don't even think of those. But your life is going to be so much. Yeah, I would say the under the sea is extremely beautiful. But the life you're going to have after this exam is, like heavenly beautiful. It's like a paradise. You are going to a paradise. Oh, I'm going to go undersea diving soon again. Yeah. So death of these corals, it's so tragic when you see those. You would feel so sorry. They are showing us this is dead, this is alive, and so on. Death of coral polyps responsible for the formation of coral reefs stops their formation and bleaches the reefs. Continuous fall of acid rains in forest areas lead to degradation of chlorophylls in plant leaves, which causes gradually death of the plants because they don't have leaves. So that is the organs that they are making food. So then they don't have energy. Death of plants from their top to the bottom is a sign of their ruin brought about by acid rains. In Sri Lanka, we don't see them much, but in abroad, some countries, they see this. We see these kind of harmful acid rains, what they have done to these plants. Acid rains make oil acidic. Owing to the acidity, poisonous metals such as aluminium, cadmium, Cr3+. Sinhala, this is Cr3+. In my one I made, I guess. And mercury and other toxic ions strongly bound to the insoluble solid structure get detached, dissolved in water because acids make these compounds more soluble. Increased concentration of these ions is harmful to aquatic organisms and not suitable for human consumption. Example, high concentration of aluminium and ferric and heavy metal ions such as is very harmful to aquatic organisms. If aluminium content is very high, that's acutely toxic. Their gills are collapsing and fish dying is occurring. High acidity rainwater bring about speedy dissolving of micronutrients, metal ions in the soil such as ferric, zinc, and copper in water, which are then leached out easily. So the soil doesn't have nutrition. This makes soil infertile. Acid water dissolves rocks and minerals in soil containing calcium, magnesium, and aluminium. Excessive ions of these in water raises the hardness of water. You know the water hardness, that it makes the scum. You cannot dissolve soap in water. Acidity increases the rate of corrosion of metal structures in constructions. This weakens the mechanical strength and reduces the lifetime. Acid rains damage statues and other artistic creations made by calcium carbonate minerals such as marbles. This obliterates, like destroying, this obliterates their fine carving. Denigration. Denigration means it's become worthless. Denigrating the historic value. It decreases the mechanical strength of houses and other constructions made by mortar and cement, which mortar mean like, the outer paste of this cement, which contain limestone. Acid rains and acidic gases convert the less soluble carbonates in mortar and cement into more soluble sulfates and nitrates. Carbonates convert into sulfate, which are more soluble, so they are ruining these structures and outer walls. Measures that could be taken to reduce acid rains and acidification of water, how we can avoid. Using coal and diesel with low sulfur content in coal and diesel power plants. Adopting methods to remove acidic gases like sulfur dioxide, like acidic gas emitted by power plants. Okay, how? Burning coal with substances that can react with sulfur dioxide. If we add calcium carbonate, at the same time it's releasing sulfur dioxide, that calcium carbonate is reacting with sulfur dioxide. By burning calcium carbonate, it is doing calcium oxide that react with sulfur dioxide, which is converted to calcium sulfate, so that SO2 cannot release to atmosphere. Converting sulfur dioxide into power plant waste gases into solid substances. Okay, here again, you can pass sulfur dioxide through this aqueous calcium hydroxide, converting it to same calcium sulfate, which is solid, so it's not releasing to atmosphere. Employing environmental friendly fuel or alternative energy sources such as solar energy, wind power, tidal energy, geothermal energy, that is heat energy, and nuclear power in place of coal and diesel. Are you guys using this solar power? I don't think it's necessary for Sinhala, but someday Ramuti, we did that. At that time, they were so cheaper, and they were given like this loans to 4% loan for solar. Then we did one like 5 million one to Colombo House and 3 million one to Ratnapura House. And it's really advantageous because they are paying us money extra. So everybody is like complaining about these frustrations of increasing these electricity bills, which we are freed from that. Okay, and now they are saying they are giving these loans and these solar facilities again. You can talk to your parents, like if you want to install this, and if you find a very good person, a good solar company, it's a must. Otherwise, there are fake companies which not generating enough solar power. So then the money is wasting, or otherwise it's really useful. And we are having that benefit, and we are earning extra money from our solar plants now. All right, global warming. For all natural processes and dynamic activities carried out by man on the earth, energy is provided by the sun. There is an empty space between the sun and all the other planets, including the earth. Because of this reason, solar energy travels to the earth as radiations, because you guys know electromagnetic radiation doesn't need a medium. This radiant energy comes to the earth mainly as visible, infrared and ultraviolet radiations. Radiation energy of the sun reaching the earth like this are subjected to various transformations in the earth. Finally leaves the earth. That is to say, there is an energy equilibrium in the earth. It's coming, it's going out. So the balance is there, unless otherwise human beings are participating and destroying this balance. Because of the transformation undergone by the radiant energy reaching the earth, heat is generated in the earth. As a result, the earth gets heated up and reaches a certain temperature. Because of the transformation of solar energy, its return and establishment of the equilibrium, the extent of which the earth is heating remains constant. So with equilibrium, you know, all these properties are getting constant, so that heating is also remain constant. Therefore, on the whole, average temperature of the earth is assumed to be constant value. This is usually about 15 degrees Celsius. However, due to Earth's this 23.5, this inclination to its axis, situation of intensity of solar energy received by various regions is different. Because of this, seasonal changes of temperature is different parts of the world is various time intervals are different. As an example, you know, I lived in Canada, so the part is there like if this is the sun, let's say this is the Canada. When Canada is away from sun, this side, so it's getting very, very colder. And also when it is getting closer to sun, it's very, very hot. So I'm not even going out at that time because it's burning our skin and everything. They like it. Summertime is all right, but the temperature is, we don't feel the temperature because the country is really colder, but the sun is then very closer to Canada. So the burning is really, really obvious. But closer to equator, it's whether there are no actually considerable seasonal change, temperature is almost same. For example, in equatorial regions of the temperature is high and it is uniform throughout the year. From the equator to polar regions, seasonality becomes acute and temperature within the year varies with a wide limit, within wide limit. The summer is extremely hot while the winter is intensely cold. In polar regions, an extremely cold weather prevails throughout the year. The average temperature on the Earth, which is 15 degrees Celsius, is a favorable condition for the existence of life. The reason for the prevalence of the favorable temperature in the greenhouse effect existing on the Earth. The potency of the greenhouse effect on the Earth helps to maintain an optimum temperature favorable for life. Okay, part of that energy is re-radiating back to Earth to maintain the temperature to 15 degrees Celsius. That actually is, we are using this phenomenon for greenhouses that we can, with whatever the country we are living, we can grow plants using this little theory so that we can have these agricultural products. Before talk about this real greenhouse effect of this Earth, let's talk about normal greenhouse effect and what is this greenhouse. Before studying the greenhouse effect, let us understand what a greenhouse is. As well as know, to grow an agricultural crops, a certain optimum temperature is essential throughout the life of the crop. Let's say within 3 months time, it needs this high temperature. So greenhouse can provide that even in very cold areas. When we go from the equator to the Earth to mid-latitude regions, the annual period of time with this optimum temperature gradually decreases. On reaching the polar regions, the time with optimal temperature necessary for plant growth becomes so short that plants do not grow in those areas. If plants grow at all, they are plants with a very short lifespan. Example, the lifespan of plants growing in tundra region. Tundra is somewhere in North Pole or South Pole, somewhere very closer to the pole. Is about 2-3 weeks. In mountain regions, a low temperature prevails year long. Example, Nuwara Eliya, Bandaragala, etc. So when I want to feel in Sri Lanka, in abroad, we can do that, we would die. But in Sri Lanka, when I want to feel this very, very low temperatures, I'm wearing a short and some skinny. And I just go out and wait like a couple of minutes. Then I'm just running inside. Yeah, but that's a good, fun experience. Until you get a little tremor, you are staying out. Then you are just jumping into water. Hence, life in a particular region, if the time interval during which the optimum temperature necessary for a certain crop is less than its lifespan, growing the crop in the relevant region is difficult. Let's say it needs 3 months, but the temperature can be maintained naturally by 2 months, so you cannot grow like 3 months lifespan plants. A greenhouse lengthens this period of optimal temperature without an external heat supply in a safe house located in that particular region. The temperature in a greenhouse is higher than 2 to 6 degrees Celsius than the temperature outside. So the temperature increasement is usually between 2 to 6, but the effect is huge. For this reason, even outer temperature is lower than the optimal temperature. It can be maintained that optimum temperature inside the greenhouse. In a greenhouse, the time period with optimal temperature can be extended by 2 to 3 weeks longer than that in the normal environment. Let's see what is happening there. Action of a greenhouse. A greenhouse is an almost completely safe kept house. Its roof and walls are made of transparent material. I think you guys have seen greenhouses. This, even Sri Lanka, they are using these wax cloths all around this greenhouse. Transparent material so that solar rays can penetrate in. Through these transparent materials, visible and ultraviolet radiation coming from the sun, passing into the greenhouse. Low energy UV are coming, okay? See that they are showing a greenhouse, it's a huge one. They are using these polycarbonate sheets, but in Sri Lanka, you know, we are poor, only some people can use these plastic sheets. Inside the greenhouse, these radiations are absorbed by the soil. So the radiations are coming in, absorbed by the soil and other substances in it. A part of the radiant energy absorbed is re-emitted. So they are absorbing but re-emitting as low energy ultraviolet and visible radiations. Okay, part is going away as UV and visible. Okay, that doesn't do anything. Another part is re-radiated as infrared radiation. This is the important part. The roofing materials and materials of the walls of the greenhouses are selected in such a way that they are transparent for visible and UV, but reflect IR radiation. So UV and visible are again going back out of the greenhouse, but they are saving this IR part, IR radiation. When IR rays are reflected inside the greenhouse for a longer period of time, they are absorbed by carbon dioxide and water vapors. See, that is the greenhouse effect that which causes the global warming, because there are carbon dioxide and water vapor. Then IR are absorbing to them and increase the heat. Are converted to heat, then they are increasing the heat. This increases the temperature inside the greenhouse. Okay, that is what happened to our Earth as well. This is the process takes place inside a greenhouse. The atmosphere of the Earth too exhibits a process somewhat equal to the action of greenhouse. This is known as the greenhouse effect of the Earth. Okay, now let's see what is happening in Earth. Solar radiation All right. Greenhouse effect of the Earth. Solar radiations falling on the Earth is mainly belonging to the ultraviolet and visible zones. Of the most of the radiations belonging to the ultraviolet zone are absorbed by the upper atmosphere and very little reaches the Earth's surface. It is UV radiation of very low energy that comes like this. Visible rays and low energy UV rays reaching the Earth's surface are absorbed by the Earth's surface or the soil. Okay, so this is absorbed by the soil and re-radiated as low energy radiations like in a greenhouse. In this re-radiation, energy is emitted as low energy visible rays and IR rays. The emitted visible rays return to space without undergoing any significant change, but the IR radiation emitted could be absorbed by certain gases in air. Fortunately, the main gas in air is nitrogen, oxygen, argon. See, if nitrogen could absorb IR, we cannot survive. And cannot absorb these IR radiation. These are not absorbing IR radiation, remember. If these gases occupying more than 99% of the Earth's atmosphere had absorbed IR radiation, the temperature of the Earth could be very, very high. See, these are the greenhouse gases. The gases which can absorb infrared radiation exist stably in the atmosphere for a long period of time are referred as greenhouse gases. Any gas having 2 or more atoms can absorb IR radiation, not single atom. See, all these have single atom, one type. 2 or more types are absorbing infrared. Also, or heterodiatomic gases like carbon monoxide can absorb IR radiation. Homodiatomic gases like these, or monoatomic gases like argon, nitrogen, oxygen cannot absorb IR radiation. Hence, any gas which is not monoatomic and homodiatomic can absorb IR rays. Nevertheless, if a gas is to act as a greenhouse gas in the Earth's atmosphere, it should have a following characteristic: ability to absorb infrared rays, ability to stay stable in the atmosphere for a longer period of time. The gases in the atmosphere which are, though capable of absorbing IR rays, unstable. If they are unstable, even if they absorb IR, still if they are unstable or short-lived, are not considered as greenhouse gases. As per the foregoing fact that main greenhouse gases, you have to remember these. There are a lot of questions in these MCQs. They are adding with this: water vapor, carbon dioxide, methane, nitrous oxide, and these chlorofluorocarbon, hydrofluorocarbon, hydrochlorofluorocarbon, that we can do about this later. These are the main harmful facts of this ozone layer depletion as well. These volatile halogenated hydrocarbons are also greenhouse gases. Although would be present in certain amount in the atmosphere, and they are capable of absorbing IR rays, these gases such as SO2, NO2, NO, and CO are not reckoned as greenhouse gases. This is because their lifespan in the atmosphere is very short. So these are not greenhouse gases, remember separately. Of the above greenhouse gases, all the gases except halogenated hydrocarbon exist in nature because these are man-made parts. The greenhouse gases aforementioned above IR rays, aforementioned absorb IR rays emitted from Earth and retain them long in the Earth. Therefore, the Earth gets heated. The result of this heating is the maintenance of the normal temperature of the Earth around 15 degrees Celsius, which is really, really beneficial. Thus, greenhouse effect is favorable factor essential for perpetuation of life, continuation of life. But why this is harmful? Water vapor quantity, carbon dioxide quantity, CH4, N2O. It's not necessary to remember these, but just get this general idea. Greenhouse gases and how much quantity is there. So they were given the percentage parts per million, parts per billion. What is PPT? That's parts per thousand. Okay. Outcome is what would happen if the percentage of greenhouse gases in the earth increases? The outcome in production of more heat in the earth due to absorption of more IR radiation by the increased amount of greenhouse gases. The heat so produced circulated longer than the Earth's course and increase in Earth's temperature. Along with the industrial ventures initiated by man with the industrial development, the proportion of greenhouse gases is gradually increasing. It increases rapidly with industrial awakening got underway after the Second World War started with the Industrial Revolution. Okay, compare this. In 1750, this is after that. I don't know how they have done this. Composition in 1750. And this is after that. See, everything has increased. Halogenated hydrocarbon, they were not producing in 1750, but now it's there. All these were even existing naturally, but now it's increasing. From table 1.6, it is clear that the amount of all greenhouse gases has drastically increased. Though the amount of water vapor in the Earth atmosphere changes with geographical factors and such weather factors on short term, the total amount of water vapor in Earth remains unchanged on long term. Because of this, although water vapor is a greenhouse gas, it does not contribute to global warming. Remember these points, they were adding to MCQs. Owing to the increase in greenhouse gases, the temperature of the Earth has risen by about 0.95 degrees Celsius from 1750. This increases 0.65 degrees Celsius from 1950. This shows that global warming has rapidly increased during the few decades of the recent past. Desertification. Human activities leading to the increasing in greenhouse gases concentration. Carbon dioxide. To meet the energy requirement of man, coal and petroleum are being burnt in excessive amount. The carbon reserves, which occurred inertly inside the earth for millions of years, were burnt in a very short time, adding a resulting carbon dioxide to the atmosphere. When the rate of addition of carbon dioxide to the atmosphere exceeding the rate of the mechanism which remove carbon dioxide from it, carbon dioxide gas accumulation in the, okay, it takes like tens of thousands of years to make this fuel, but to burn this fuel, it takes seconds. So it has this huge imbalance now. Because of excessive deforestation, destroying the forest makes the forest land area is decreasing. Trees are fells indiscriminately. The debris contain carbon reserves collected over hundreds of years. When these are decomposed by microbial activities, carbon dioxide is added to the atmosphere. This causes the carbon dioxide content in the atmosphere to rise, methane. When the indiscriminately disposed organic waste decay in the environment, they are acted upon by anaerobic bacteria. When those bacteria decompose organic substances, methane is produced. Disposal of urban waste as a heap of garbage is also a reason for the production of methane in large amount. That what happened that Mathotaarachchi, that garbage dump yard, that there was this huge landslide after this burning of methane. Agricultural practices, paddy cultivation, undertaken in marshy and waterlogged areas, favors anaerobic decomposition of organic substances producing methane. That's how they are making methane. Anaerobic decomposition of organic substances produce methane. Methane is also produced in the guts of ruminants. Ruminants are like cattle, sheep, and goat due to bacterial decomposition of plant material under anaerobic condition. Have you guys seen that we had this cows in my grandma's place when I was in my childhood? At night, daytime, they are just eating grasses. Nighttime, they're just taking it back somehow from somewhere from here to here, like lumps of them. They are just coming. Then they are chewing like continuously. Then they're swallowing it. And another part is coming. So that is going through this anaerobic oxidation. From that, they are making this methane. That's a huge problem in farming. During farming, they are using a lot of this, the animal stuff. Therefore, rearing such animals in commercial scale is a reason to release methane in large amount of to atmosphere. Crude oil mining too increases the methane content in the atmosphere. During the mining processes, methane gas occurring as natural gas in crude oil deposits in free to the atmosphere. During the mining means sometimes this happen even in SEARS, it's not SEARS mines, in gem mining as well. So when this methane is produced, all of a sudden methane is producing, all of a sudden if you lit something like, the candle or something, it's burning. So before they are, because these tunnels are going like, the longer down, then the tunnels are going when they are, excavating these gems. So before they are going down, they are just putting this lightened candle down there to check whether methane is there. There were a couple of accidents that people burned because they were being silly not to check those. Okay. Greenhouse halogenated hydrocarbons, gaseous halogenated hydrocarbons. Those are these. Halogenated hydrocarbons are very powerful greenhouse gases. These are tens of 1,000 times as strong as carbon dioxide. For this reason, presence of these gases in the atmosphere, even in small quantities, contributes significantly to global warming. Halogenated hydrocarbons are scarce in, this is not scarce in nature. Halogenated hydrocarbons responsible for increasing the global warming are chlorofluorocarbon CFC, hydrochlorofluorocarbon HCFC, hydrofluorocarbon HFC. And they are giving different names for these numbers that as standard. Some halogenated hydrocarbon molecules. If you are not writing this essay question, that the question number 10 of your new syllabus, you don't want these structures, just a little idea is enough. But if you are writing the answer, then you would need them. All these three types of compounds synthesized by man and are used as cooling gases in air conditioners and refrigerators. These gases are using in air conditioners and refrigerators. They are also used as a blowing agent in the production of plastics and in aerosols. Like blowing agents mean like you are making like rigiform kind of structures. For example, deodorant spray and pesticides in aerosol sprays. In repair of disposal and disposal of above equipment, these compounds enter the atmosphere. The atmospheric lifetime of these are hundreds of years. And once they are making these free radicals, they are continuing life forever. Adverse effects of global warming. With the global warming, polar ice caps and glaciers in high mountains areas tend to melt while the ocean water expands. This entails in inundation of coastal lowlands. Example, Ganges River in Bangladesh, the Delta River in Brahmaputra, Mekong Delta in Vietnam. I think you've done some part of this for all of us. Yeah. Loss of settlements, destruction of coastal ecosystems, infertility of soil caused by seawater swamping inland, and devastation of crops are the outcomes of this. Moreover, it may obliterate Maldives and many other small islands, states in the Pacific Ocean completely from the world map. They are just saying that someday the Maldives would disappear from the map. Because of that high temperature epidemics, dengue, Ebola, COVID, MERS, SARS, all are possible. Now they would concentrate more on COVID. Spread fast. Increasing in the number of hot days and decrease in the number of cold days per year. Occurrence of strong heat waves more frequently and lasting for a long period of time. Remember that we had this heat wave like a couple of months ago in Sri Lanka? At what time? I think it's in April. Yeah, we went this, what? We went to somewhere, to the north side, I don't remember. What is this? Pasiguda, yeah, Pasiguda side. When the temperature outside was like, I think 40 or something. 40 or 42. So we were just get out of this vehicle. We just want to feel that temperature on the way, not in the hotel. So we were waiting outside, like, you know, a couple of minutes, like 3-4 minutes, you can stay out. So much it's like you are in kind of an oven condition. And you can't even open your eyes, like, you know, the sun shines so badly. And those are the heat waves. In India, I think these animals are getting died with these heat waves. Not only animals, I think even people are getting died. Frequent emergence of hurricanes, tornadoes, and greater violence. Very recently, there was this tornado condition in Sri Lanka that I don't know whether you guys seen for news. They said that one of these ladies were just pushed up, and then she was falling somewhere else with wind or something. Tornado means, like, you know, the circular wind is going up, hurricanes, and you know. Usually we don't have any of this in Sri Lanka. We never experienced, but I think you have experience in England, darling. Did you? Because this wind is so fast, sometimes it's pushing you. Like, you can't walk. If you try to walk in that faster wind, you would fall. I had that once. I had that experience because people know that they're not going out. I didn't know that, and I thought, like, oh, just wind, who cares that? Because I never had that experience. But if you are going out, luckily it was like a grass field, so you cannot walk. The wind is that faster, you are just falling down. You cannot walk. It's like somebody is pushing you. Rapid spread of invasive plants and animals. Such plants and animals may encroach new areas. Cold-blooded animals like snakes and other reptiles would migrate to cooler areas, because cooler areas now getting more warmer. Excessive drying of some regions, South Asia, Central Africa, while some other regions, Europe, receive heavy rainfalls. Frequent long-standing droughts and flash floods due to heavy rainfall in a short period of time. That even happened to Sri Lanka, because we don't have exact this rainfalling pattern now. Even the meteorological government cannot predict when would be the rain, because it's changing. Global climatic changes. Many human activities in the world are connected with the climate of the relevant region. For example, agriculture, animal husbandry, tourism, and pottery are strongly linked to climatic patterns. These climatic patterns are created by the differences in solar energy receiving by various parts of the world. The shift of energy circulation caused by the global warming brings about changes in the climatic patterns. Not receiving rain on time, untimely rains, droughts, and occurrence of whirlwinds and tornadoes in regions where they have not been experienced before are examples. Prolonged droughts causing desertification, formation of deserts, in some regions forcing people to leave those areas. Climatic changes may indirectly engender political crises among national and even battles because unsuitable areas they are just migrating from. For example, when the citizens of a certain country are displaced, they migrate to neighboring countries and a need arises to provide political asylum for them. Political crises and wars may erupt for sharing water in rivers common to several countries. Example, Nile, Brahmaputra, and Mekong, especially when water goes scarce. Global warming and climatic changes caused by it is a problem common to entire world. The most affected by this are the underdeveloped and developing countries, which contributes least to global warming. So, in order to control global warming, all the countries in the world should get together and have to adopt measures that minimize the emission gases which cause it. The following solutions could be suggested in this regard. Limited the burning of fossil fuels and inclining to use alternative fuels. The best option is solar energy. In addition, nuclear power and wind power be used. Updating the machinery of current use and increasing their fuel efficiency could also be done. Instead of fossil fuels, it is suitable to use renewable sources of energy such as ethanol and biodiesel. The amount of pure carbon added to the atmosphere by this combustion of biodiesel is nil. They are saying that the net increasement of carbon dioxide is zero. By getting used to a simple lifestyle that hard, high energy demand essential for the luxury life can be minimized. You can reuse all the stuff. Minimizing deforestation. To make furniture and paper and obtain firewood, fast-growing plants can be used without destroying forest. Avoiding indiscriminately waste disposal and adopting systematic methods of waste disposal with proper management of waste. This minimizes the emission of methane to atmosphere. Refraining from the consumption of meat as much as possible, getting used to vegetarian diet. Unless others, yeah, vegetarian. But this rearing, by this rearing of animals such as cattle, goats, and sheep, for meat can be minimized. It's not for us, it's for like these Western and Europe countries who's basically surviving needs. Use of composting in place, use of compost in place of human fertilizers. Sorry. Use of compost in place of chemical fertilizers. This helps minimizing the emission of nitrous oxide. See what happened to Sri Lanka because they wanted to replace these chemical fertilizers with compost. Restricting the use of refrigerators and air conditioners for using the such machines with less powerful gases such as hydrofluoroolefins, we're going to talk about later, isobutane like R600 that there is this commercial in TV, and coolant gas like ammonia in place of more stronger greenhouse gases like CFC and HCFC. Okay, let's write this page number 70. Okay, next week we're gonna finish your full syllabus. All right, let's stop there. Exactly 12. I am ending the meeting. Just request a record.